molecular level. In the overview of this presentation, we're going to try to aim to understand the effects of creatine on muscle cells and if it has the potential and opportunity to create a better performance in exercise. That could be for athletes or non-athletes, just during physical activity, etc. And I'm interested in this because it can be important for athletic performance. And throughout this presentation, we're going to focus on the question, can taking a supplement of creatine increase the strength in muscle fibers on a molecular level? And to further look into this, we're going to look at what creatine actually is and how it works in providing muscle energy. And then there's different types of creatine supplements that you can take. And we're going to look at how they differ and what they both do. And then lastly, we're going to talk about it overall and then the references that I used. So the biological question and why it matters. So the question we're looking at is, can creatine create a better performance in our muscles? And can this help as we age, when generally our muscle mass does decrease over time and bones do become thinner, making them more likely to break, making our bodies more susceptible and easier to become injured? For example, when people fall, a lot of times they do end up breaking something. And furthermore, can this help athletes perform better in their sport by creating more entertainment for the public, more competition, and even harder athletics? And what does creatine do to connect to ATP and energy? Now, first off, what is creatine? Creatine is a type of amino acid that is located in your body's muscle and brain tissue. Now, it is something that the body does make on its own, and it is their natural resource of energy. However, you can take a supplement of creatine to increase the amount of creatine in your body, and then majority of the body's supply naturally is produced by the liver, the kidneys, and then the other half, or the remaining amount, is consumed through your diet, which comes from red meat and seafood. And then creatine is stored as phosphocreatine in the body, which is located inside muscle fibers, and that's what is broken down to make ATP. So going further into this, how creatine works in providing the muscles with energy. So for example, when we're contracting a muscle, that muscle is using up energy to be able to move, right? And so we are using ATP that we have stored, right? But as we're using that ATP energy that we have stored, we're getting depleted of the energy. So we need to make more. And when we do this, we're using, like we talked about in class, aerobic respiration to make more ATP. So how creatine comes into this, it is phosphorylated to creatine phosphate, which acts as a buffer and becomes a phosphate donor in the conversion of ADP to ATP, which is the stage of oxidation phosphorylation. Now, this buffer that creatine creates adds a little bit more efficient and a faster way to be able to create this ATP, which increases the overall amount of ATP created. So, because of this, we're able to make more ATP at a time, and it's able to last longer because we have creatine in our body. So when we take a supplement, we're allowed to have that buffer go for a lot longer, which allows more ATP to be created at one time and to do it for a longer process of a time. Now, the types of creatine supplements, there's three types. There's creatine monohydrate, creatine ether ester, and creatine hydrochloride. Now, they all three do very different things, and knowing what they do is very beneficial. So, first off, the most common, creatine monohydrate, is made by bonding creatine to a water molecule, which your body has a lot of water molecules, making it more abundant, the most effective, and the easiest for your body to process. Because we are taking a supplement which is not something that our body naturally makes, so our body can react differently to it, might not react good to it. So then the second one is creatine ethyl ester, which is made by bonding creatine to ester salts, making it more biodegradable, better for the environment, better for your body overall, but not as effective as the first creatine monohydrate. Lastly, we have creatine hydrochloride, which is made by bonding creatine to hydrochloride molecules in your body, which makes it more acidic, which can have some negative reactions to that. And so HCl is more soluble in water, making this to be more absorbed by the body, but again, the least effective of all three. So in conclusion, we can say that there is no conclusion to creatine and better performance, but we can say that it helps with the process of creating ATP. So therefore, our muscles will have a lot more energy and possibly have our energy for a lot longer period of time, allowing for someone to go harder in exercise, have more energy to go longer during exercise, etc. So it helps, like we said before, it helps create the process of creating ATP going for longer, and it helps speed it up a little bit and creating more large amounts of ATP in a short period of time. And athletes can use this to their advantages while doing these workouts that and working their body, because they'll have more energy to keep going, and muscle fatigue will be significantly less. Now, the extra supplement is also not needed because the body does make creatine on its own, and we do ingest it through our diet. However, by taking creatine, it can help increase the level of energy that we are creating in our body. However, it will not just make us stronger by taking the supplement. So here we have some diagrams for anyone who needs a visual reference. So in the top, we have the chemical structure of phosphocreatine, showing the molecular chemistry on how it goes from ADP to ATP. Then on the left, we have a diagram about showing how creatine implements into the ADP-ATP creation. So we have ATP at the very beginning, body's energy source. Then we talked about at the beginning, the energy is being used, and ADP being created. And then that creatine supplement that we took at the beginning of the day is now being implemented to help with ADP reforming into ATP. Therefore, we have more energy. Now on the right, we have a diagram explaining the aerobic respiration like we learned in class. And therefore, we can see the creation of ATP. And the creatine will just speed this up and again, allow it to go longer, making more ADP overall. So for my primary source, I was able to find a lab report based on a experiment that was done showing the effects of creatine supplementation in the resistance training exercise on muscle insulin, which looked at if creatine was able to provide strength. And here it showed that it was able to provide energy and not strength. So this is one of my main sources that I was able to use, pulling that information and it was a primary source because it was a lab, first-hand experience, first-hand results, etc. So my second is kind of an overview of the lab that was done, and it is creatine supplementation with specific view of exercise and sports performance. And they ended up using that lab report as a reference when they wrote this. So it was kind of an overview explaining the why the results were those results, where my primary source was giving me the results. So this was kind of a summary of my primary source. And then my last source is an article just explaining what creatine is, and it's from Mayo Clinic, which is basically kind of like a medicine website that kind of tells you what things are, and I kind of use it as a textbook, so that is why I had it as my third source.